Hello guys, welcome back to Math Without Tears. Now, looking at number 3, we have the exponential of 3x minus 2y, x squared exponential expo of 2y. You know the rules of exponents, applying the rules of exponents. Rules of exponents, 7th grade, 8th grade. Right? Form 3, Form 2. Now, this is equal to exponential of 3x times exponential of negative 2y plus x squared exponential of negative 2y. Now, this is equal to, remember, whenever you have two quantities common in a sum, you can factor out one of them. So we can factor out exponential of negative 2y times, if we factor that out here, it's going to look like all of these divided by that. So we're just left with exponential of 3x plus x squared. Because exponential of y is being factored out. If I open the parentheses using the distributive property, if I use the distributive property and open the parentheses, you're going to see that I multiply out, I'll have this product. If I multiply again like that, I have these ones. So I haven't changed anything. Now let's keep going. This is the dy by dx. Now I can go ahead and separate. Remember, I can put this over 1 and I cross multiply. I want to separate the variables such that everything that has to do with y goes with the differential of y. Everything that has to do with x goes with the differential of x. So I've grouped the terms that have to do with x and that which have to do with y. So let's go ahead and separate them. Let's first of all cross multiply. We have dy equal to expo of negative 2y, expo of 3x plus x squared dx. But then we cannot go ahead and apply the integral sign because it's not yet in the standard form or in the form p of y dy equal cure of x dx. It's not yet in that form. We still have y right here. So how can we get rid of expo of negative 2y? We can divide both sides by expo of negative 2y. That's one way. Or we just go ahead and multiply both sides by expo of positive 2y. This is what I mean. I can multiply both sides by expo of positive 2y. And then I come here, multiply both sides by expo of positive 2y. Now, remember, 8th grade, Form 3, we know that from indices or from the rule of exponents, a raised to the power m times a raised to the power n equal to a raised to the power m plus n. So I can literally add expo of 2y plus negative 2y. This is expo of 0. Anything raised to the power 0 is 1. Meaning that all of this is 1. And now I can conveniently write expo of 2y dy equal to expo of 3x plus x squared dx. Now, this looks exactly like the standard form of a variable separable differential equation. I can go ahead and apply my integral signs. on both sides. The indefinite integral of this, remember this rule, whenever you have expo of a linear function, not any a linear function, with respect to y, you have to differentiate the exponent and put it as a denominator. If I differentiate 2y with respect to y, I have 1 over 2 expo of 2y. Normally, I'm supposed to say plus k, okay? If I say plus k1, that's correct, no problem. I can go ahead and integrate this side. I have 1 over 3 because when I differentiate 3x with respect to x, I have 3. So 1/3 expo of, I maintain the 3x. If I integrate x squared, I have x to the power 3 over 3 plus another constant k2. I can put these constants together to form a single constant. That's why sometimes you don't bother yourself putting constants all over the place. You just put one constant at the end because it's just going to account for whatever constant that was supposed to be on the other side. So I can go ahead and put this as expo of 2y equal to 2 over 3 expo of 3x plus x cubed. And then k1 goes to the other side to give k2 minus k1 of course. This gives you expo 2 over 3 all right, so I combine k2 minus k1 times 2 to give me a constant. It's still a constant, k. So this is the general solution of, now I can continue taking ln of both sides and making y the subject of formula. That's no problem. That's no problem. But then this is the general solution of this differential equation. For the purpose of time, we are going to solve number 4 in the next video. So guys, see you in the next video.